So I'm very sorry that you cannot see me, but believe me, it's not a big loss. Michael knows how I look alike, so he can confirm this. Now, after Boris told us about how to make lenses smaller, and Michael was talking about to make small things visible on a big screen, I decided today to talk about lenses for large line and area sensors, and also, let's say, the challenges we have to match them somehow. No. So what is needed? So just let's have at first a small look about why there are different sizes of imaging sensors. Because normally you think, oh, the world is getting smaller and smaller, as Boris already told. And it's also the sensors on the one hand are getting smaller and smaller. So there are in the meantime 1/3, 1/4 inch sensors with pixels smaller than 3 microns in the market, which allows pretty small and lightweighted cameras and with a pretty high quality. But nevertheless, as we said, we have here very small pixels. On the other hand, these large sensors are also getting larger and larger, so up to 67 millimeters. So we are really going, that was in former times the mid format. But also here, the pixels are getting smaller and smaller. But nevertheless, there must be an advantage why we need these large sensors. And the advantage is, I think, very clearly, you get more pixels. The pixels are at least a bit bigger than the others. You have got less noise, and at the end of the hand, you have got more information for your application, whatever it will be. For this, I will come back later. So why large sensors? As I said, it allows you a higher resolution or a higher number of pixels. It allows you a lot of more information due to the fact you have got more pixels available. And for this, you get more details. You can also say more resolution, more sharpness in the picture so that you can make the more details visible. And at the end of the day, this is always a bit struggling, but you also can catch more light on this area. So the next topic we are talking about here a bit is we are about line sensors, line scan sensors. Everybody can ask and say, why do we need a sensor which is just one line with 1, 2, or 3 pixels, depending on the application, depending on the camera, depending if you have got a monochrome or a color camera, which makes slightly differences in between. Also here, the simple answer is here you get more information. Just for example, I've done some simple researches. The IMX 461 has 11,000, a bit more, 11,648 pixels in one line. And a 60K sensor has, as the name said, over 60,000 pixels in one line. So you have got, if you have got a certain application, the most possible information out of the sensor. And this also means that with a 60K sensor, I can cover a wider field than any other area sensor at the moment in the market, I would say. Then the other big advantage is that you have at that moment less data, which you have to read out and which you have to work on later in the computers. This saves at the end of the day, it saves time. Which also means you have got a higher speed in the imaging as a result. What does this need at the end of the day for a lens? You need lens with a huge, or at least a bigger image circle that fits the size, which can enlighten the size of the sensor, which also has as consequence that your lens itself will get bigger and larger. Ideally, especially for line scanning, it is very important that you get a homogeneous MTF over the whole image circle. So as you can see here in the MTF, which shows us, sorry for doing some advertisement for our products, a diamond lens out of our assortment, which was especially made for line scan application, but can also be used for high quality area scan applications. So, which also mean I've got a relatively illumination, which also should be pretty homogeneous over the whole field. And last but not least, you need a good and a low distortion overall, so that you can afterwards, if you have to stitch the pictures, especially in the print application, that you have got 2 or 3 cameras side by side, so it is easier to stitch the images together. Nevertheless, bigger lenses means also you have got some challenges to solve. You have less space for tolerances, which means in the production you must be more precise in grinding and polishing the lenses, and also at the end of the day to put them together. We have also to go really to the limits of the physics, which means to get here the best possible quality you have to go to the diffraction limit of the lens, which means you have to take the lens as it is. So to get a higher depth of field, which normally means to close the f-stop, is in that case not possible anymore, or only with a loss of quality. This means, but on the other hand, normally you have here high magnifications, 1 time, 1.5 time, or a half time magnification. Also here, the depth of field is pretty limited, which also means, again, for a line scan application, for example, is, I wouldn't say only, but nearly only possible, for example, everything which is pretty flat, like a paper inspection, PCB inspection, for example, flat screen, display, something like that. Which also shows the next point, due to these larger sensors, the lenses must be more and more specialized. So these generalized lenses, like a C-mount lenses, which has a focus or magnification range, is in that case not possible anymore. You get more and more a flat or a larger image circle, and this also really limits the possibilities to generalize a lens. A nice help, especially here also for line scan, is that our lenses, especially our 3 lenses for line scan, has a so-called azimuth marking, which is on 90 degrees to the line of the highest sharpness, so that it is easily for the operator to bring the lens to the optimization to the line scan. Here on that slide, I tried a bit to show on the graphics what decisions must be made to get an optimum out of the lens. So I have to make a compromise in the depth of field and high magnification. So if I have an application, for example, where a high magnification is very, very important, in that case, I have to accept that my depth of field will be limited. Or on the other hand, I want to have I really want to say a cheap lens. And I want to have a flat MTF. Also, this is mostly not to get in one line. Or a high magnification and a high working distance is also mostly not to get in a pretty good agreement. And so this means also for us, if somebody is using a large area scan camera, we have to talk to our customer, to our clients, what exactly do they want to do, so that we can make a choice for the good choice for the right lens. For the next few slides, I really would like to go a bit to the application and what challenges we have and really what we have to think about this. I already mentioned as a typical application printing. What does this mean? You have got a white field, because these paper bands, what they are running through the printing machine, are mostly several meters wide for a newspaper, for example, or for some advertisement. This means that you have got several, mostly 2 or 3 lenses side by side to cover the whole range. Mostly have you here a line scan with a width of 82 millimeters. So we are also here limited in the choice of lenses. You need a high resolution possible. So we need a 60K camera, mostly about, let's say, between 3.5 and 5 microns as pixel size. Which the life makes a bit more challenging, as it's mostly we are also here using color. Perhaps we want also to check the color if they are correct. So we need more than one camera mostly to cover the whole field of view, and this also means afterwards we have to stitch the image, which makes a line scan easier. As we learned before, we have a reduced information or data quantity we have to transfer. So the check here, or the goal here, is definitely that we have here to check the quality and the printing image if everything is fine. What we have to think here about for the lens, for sure we need a wide image circle. Sometimes we need also a wide opening angle to cover everything. We need a high color correction, and last but not least, the lowest distortion, the homogeneous relative illumination. For these lenses, we are here have in our assortment, for example, our Pirate series, which I think is pretty well known, and also our zirconias, which are really easy to handle lenses, also especially for this application. I wouldn't say more or less the same. It's also paper production. Also here we have a bit more challenges. Also here the quality check, but here because the paper is normally, let's say, it is white mostly, and you have to cover some detecting some scratches or some streaks and cracks in behind. But you have got here a low contrast, so you need here a high resolution. You need also, due to the width of the whole field, large line sensor cameras, 60K, as I said, with high resolution, ideally with 3.5 microns, which makes a high efforts in resolutions at the lens. Also here, mostly here, it will try to cover it with one camera, but mostly it is not possible. So also here, I repeat myself now, we have to cover a good image quality in total. Our recommendation as lenses here would be, again, the Pirates, because they are, how should I say, it's the most generalized lens we can offer here in this case, but also a really high end lens, the diamonds. For smaller machines, we can also give our new to light, which has a good high resolution and a wide field and is covering a good sensor up to 28 millimeters at least. Yes, as I said, wide field for view, lower magnification is here good to have, and at least nearly no distortion. And due to the high resolution, we need a good and constant MTF up to the edges. Solar inspection. I think due to the politics and also to our problems what we have in climates, it is getting more and more important. Also, we have here in Germany, it should be taken back to Germany production. So it is getting also an important market and important application. But here despite to the paper and to the printing inspection, it is very important that you have got here a large area sensor with a high resolution, or let's say pixel number to be correct, larger than 25 megapixel. Also here, I would say detecting for damages in any way. Are there any scratches? Is the bonding of each panel correct? Do we have any connection where it should be? Is the frame proper, and so on? So for this we need high contrast and a high MTF. And last but not least, we need here also a high magnification. Magnification of 1x and higher is here pretty normal. And also, as I mentioned, the high MTF, just that you get every single detail over the whole sensor of the size of the sensor. I think this is now my last example for a battery inspection. It is more or less the same like in for solar inspection. Here, normally it detected the layers in between every battery cell. They must be okay. So there could be some scratches in, some broken, and for this we need also again high magnification, as I said, 1 time, 2 times and higher, high contrast, and a good MTF for the whole field of view, so that you can see even the smallest scratches at the edges, which is pretty important, I would say. Yeah, I just told them I want to make a bit of advertisement for our products. I already introduced them at least. Our 2 Lite, our latest, is possible up to 32 millimeters. Our Pyrite, not Pirate. Pirates are something evil. Pirates are pretty good. Are used. We have got this in several focal lengths and image circles up to 100 millimeters. And now then the zirconia, sapphire, and diamonds are special made for, especially either for line scan or really for the display inspections. For this they will be developed. So now I'm at the end for my short presentation. Thank you very much.